Hello, Science Nines, and welcome to a lesson on chemical and physical changes. My name is Mr. Van Leeuwen, and I'm going to be doing this lesson with you. What we're going to cover is a few things in this particular lesson. So, first of all, learning intentions are how to describe and apply different ways of classifying materials based on their composition and properties, your success criteria, and I'm going to have to move my. Oh, no, we're good. It's not hiding. I can explain the difference between physical and chemical properties, and I can describe and identify objects' physical and chemical properties. So, properties of matter. Properties are characteristics that can be used to describe a substance. So, for example, how would you describe yourself? Describe your appearance, describe your personality. Those are properties of you. Now, when we take a look at matter, we can actually classify properties into two big groups. They're either physical properties or they're chemical properties. And then that actually goes into whether we have something happening that's a physical change to matter or a chemical change to matter. So, a physical property describes the appearance and physical composition of a substance. And this can be observed or measured without forming a new substance. The really big thing here for a physical property is in order for us to see it or observe it or test it, we don't actually have to change the chemical in terms of what we have. So, for example, if I said something was flammable, that is not a physical property because I'd have to burn the thing in order to prove that it's actually flammable. And when I burn it, I've changed the chemical composition. I've done a chemical reaction. So that would instead be a chemical property. If I said something's shiny, that's a physical property because I can prove that without actually changing the substance. I can just look at it and see that it's shiny, or it's yellow, or smooth, or whatever. Those are all physical properties. So they're things that I can test or show without doing a chemical reaction, without changing the substance. I'm sure there's going to be a slide on this, but the really big confusing one is when we have state or phase changes. So if I say ice melts, you could be like, oh, you changed what you had, but I didn't. It's still water. It's still molecules of H2O. They're just connected and moving in a different way than they were before, right? We'll get into that when we get into phase changes, but that's not actually changing what we have. It's still water. It's just now in a different state. So, in other words, the particles are moving differently. And liquid water, now they can move around a little bit more from place to place. They're rotating. Well, in a solid, they would just be vibrating in place as ice. So when ice melts, that's a physical change because I still have water. Now, when I look at physical properties, they can be classified as either quantitative or qualitative. And I don't have my drawing tools here, which is unfortunate. But we're going to talk about what that means as well for quantitative or qualitative. So quantitative is when I have something that is measured by an instrument and I have a number as a result. So really how you want to think about it is that it has a number attached to it. So it's numerically measured. So some examples: height, mass, density. These are actually all quantitative things. I don't love number of bubbles being there because that does not take an instrument to actually measure it. So essentially quantitative by definition, as we go into Chem 20, Chem 30, Science 10, etc., will be number measurement that came from an instrument. So, if you actually measure the length of something with a ruler, that is a quantitative property. Qualitative properties are qualities. So if you look at the root words of these, that's important, right? When I look at quantitative, that's quantity being the root word. Qualitative, it's qualities. So qualitative characteristics are qualities that are observed. So examples: color, smell, texture. These are all things that I can just talk about and observe essentially as qualities without an instrument or a number attached to it. So how do you distinguish between these two? Well, quantitative has an N in it. Yeah, N. That N I want you to think of as standing for number. So if it has a number in it, it has a numerical kind of value, then you know it's a quantitative thing. Or again, look at the root of the words of quantitative or qualitative. All right, so little quiz here. You think about it, and then I'll tell you the answer. He is very tall. Think. Qualitative. Next, he is 7'4". Think quantitative. And that would be quantitative because it would actually take something to measure it. His shoes are white. Qualitative. I do not have to measure that with an instrument. There is no number attached to it. So the big distinguishing thing that you're thinking about is, does it have a number attached to it or not? And if there is a number, it's quantitative. If there is no number, it is qualitative. All right, chemical properties. Describe how a substance interacts with other substances in order for a chemical reaction to take place. So in a chemical property, when you're observing it, you are changing the actual substance you have. Some examples of chemical properties are things like, does it react with an acid? Is it reacting with water, like sodium reacting with water? Does it react with oxygen, like combustion reactions or corrosion? If I heat it, does it decompose? Does it change what actually is there? Right? These are all things that are chemical properties. Toxicity as well, because it's doing a chemical property in the living thing. Ability to burn, so combustibility, we already talked about that one. And then how stable is it is also a chemical property. We're not going to watch this video because I don't have the system audio coming through. All right, next thing we're going to talk about, very closely related, is I am learning how to identify conditions under which properties of a material are changed and decide if a new substance has been produced. So success criteria, I can explain in a sentence the difference between a physical and chemical change, and I can classify different examples of physical and chemical changes. This is so similar to physical and chemical properties. So physical change is when a substance undergoes a physical change. It may change state or how it looks, but its composition stays the same. So we talked about this with state changes. When you have ice turning to liquid for water, right? This is just a physical change. It is still H2O. It just has changed how it's attached. So essentially what's happening is that we still have the same chemical, but the movement of the water molecules inside of the ice has changed. So now it's moving in a different way. So some examples of things that are physical changes where I haven't changed the chemical at all, I don't have new substances being created, is things like dissolving, changes of state, if I cut stuff in half, if I mix two things together and it doesn't react. These are all physical changes. The really big thing, though, is those state changes. That's what people get most confused about. And just a reminder that state and phase changes aren't a chemical change. It is simply physical. All I'm doing is changing the type of motion between the particles. In chemical changes, I'm always making something new. I'm forming a new product that was not there before. Okay, so I'm making something completely new through the process of a chemical reaction. How do you know a chemical change has happened? There's a few things you can look for. Was heat produced or absorbed? Was there a change in color? Did you have gas bubbles forming, which means you had a gaseous product that was formed in liquid, or something called a precipitate? So did you have a solid forming in solution, so in water? This is kind of neat when you see it. You should look up precipitates on YouTube. One that's really good is actually potassium iodide and lead to nitrates. So potassium iodide precipitate is like this amazing bright yellow color. So you mix together potassium iodide, which is clear, and lead to nitrate, which is clear, and then you get this yellow powder solid forming in that solution. Really neat to see. So whenever you have a solid that forms in liquid, right, that's not a phase change, but a new substance being made, we call that a precipitate. So these are some things you could look for to tell you that, hey, maybe it's a chemical change. There's some pictures. That's actually a picture of a precipitate, or maybe that's bubbling. It's actually hard to see from that particular picture. Oh, look at that energy. All right. So a starting material is going to be used up or it's going to change. We have a new material with brand new properties that's being formed. And the change is difficult or impossible to reverse. I'm as a chemistry guy, that one is a little bit icky for me for the slide. We'll talk about why. The guiding question you should be asking yourself is, did you make something new that was not there before? If a new substance was made that wasn't previously present, you know it's a chemical change. It's a chemical reaction. Okay, if the particles are the same, you didn't make a new substance, then that means that it was simply a physical change. The reason why I'm a little bit iffy on this last one, of the change is difficult or impossible to reverse, is that there are some chemical changes that actually are really easy to reverse, right? Like you think about, and I'm getting too complicated here, but you think about if you split apart water into hydrogen and oxygen, you just put a match and boom, now you got water again, right? When you plug in your cell phone, you're actually reversing a chemical change in a lithium ion battery. But that can be a guiding question of asking yourself, is it really tough to reverse? But again, the guiding question, the thing you should be asking yourself is, did something new get made that was not there before? And if something new was made that was not there before as a substance, then you know it's a chemical change. And these are the signs you can look for: heat produced or absorbed, change in color, gas bubbles forming, precipitate forming, that can guide you onto whether something was made that wasn't there before. Just talked about this actually. This is kind of neat. We can split apart water into hydrogen and oxygen. This is done in something called a Hoffman apparatus, which is what this picture is actually of the Hoffman apparatus, where I connect a power supply to water that has like normally an electrolyte like sodium sulfate in it. And then from there, I actually can make, as electricity goes through, hydrogen gas and oxygen gas. Here's kind of a fun question. Why is the balloon with hydrogen gas twice the size of the oxygen gas balloon? You can think on that one. But what's happening is water is producing hydrogen and oxygen gas. So when I look at that, I can know that a chemical reaction is happening because I actually see the bubbles, right? Showing me that new gases are being made. And I would actually see a bubble on both this side and this side because I'm getting hydrogen made here at the cathode and oxygen getting made here at the anode. So this would be a chemical change. I'm making something new. Rusting, chemical change. I have iron and oxygen, it reacts, and I end up getting iron 3 oxide. Again, how do I know? Well, I got a color change that occurred. I've made a new substance. I can tell that something new is there, right, by looking at the rust. So that would be a chemical change as well because I'm making something new. Cooking an egg, that is a chemical change. You can tell by the change of color, consistency, right? It's not looking the same as it was before, and it takes heat in order for it to happen. So that is actually absorbing heat. It's an endothermic reaction. What's actually interesting is scientists have uncooked eggs. This is a thing that they've actually done in labs, that they've actually decided that they would try to uncook an egg, and they were successful. Hooray! Does this have any practical applications? No, but we did it. So color changing in a leaf. Do we think this is a chemical change or a physical change? Well, you got to be thinking, all right, it changed color. So I probably have something present with the color change that was not present before. This is a chemical change. Baking a cake, chemical change. Rotting fruit or food spoiling, chemical change. Water evaporating into the atmosphere. Well, that's a phase change. So that would be a physical change, right? The water is moving in a different way to evaporate, but it's still water. It's still water. Okay, maybe you might want to just kind of like pause this video and try out the last three and try to figure out, is it chemical or physical on those three? So think, pause now, and here are the answers. Soil erosion typically would be a physical change, right? Just soil moving from place to place. There's some kind of like weird stuff that can happen around that, but we're not going to get into it. Boiling an egg, we kind of already talked about that with cooking an egg, frying an egg. That'd be a chemical change, right? I have a color change. I have cooked egg, which was not there before. Butter melting in a pan, as long as it's not turning brown and it's just simply melting, that would be, again, a physical change. It's a state change. Oh, another kind of group of ones here. Yeah, pause. Yeah, pause. Try it out. Come back. Okay, digesting food, that's a chemical change for the most part. I mean, the chewing in your mouth, right? That's physical, but then as soon as it's getting into your stomach and even a little bit in your mouth, you've got some enzymes. I think amylase is one in your mouth that starts digesting polysaccharides. But digesting food as a whole would be a chemical change, right? Because you're making new things that were not there in the original food. Silver tarnishing, that's chemical as well, making silver sulfide. Chocolate bar melting in the sun, that's physical, right? It's a phase change. Chopping a block of wood into two pieces, that's again physical. It's still wood, I just now have more pieces of it. All right, so that is basically it, chemical and physical changes. Hopefully that is, pretty clear in terms of what we have. So just a review of what we talked about the fact that we have chemical properties and physical properties. Right, physical properties I can observe without having to do a chemical reaction. A chemical property I can only observe when I do a chemical reaction and make something new, like combusting. I have quantitative and qualitative properties. Quantitative have a number attached to it, and they're measured by an instrument to get that number, while qualitative uh, does not have a number attached to it. It's basically a quality of that. And then I have chemical and physical changes. So physical changes are things where I haven't changed the particles, I haven't made something new, while a chemical, I have made something new, a chemical reaction has occurred. All right, that's it. Have a good rest of your day.